Hello everybody and welcome back. We're going to be continuing on as we started in the last video. We started with question number 1 of the 2005 Friar Mathematics Competition. So in this video we're just going to keep rolling. We're going to go on and take a look at question number 2. So let's jump into the paper and take a look at things. Alright, question number 2. It involves a game with people whose names start with A and B. Alright, so let's take a look. A game begins with a row of empty boxes. On a turn, a player can put his or her initial in one box or in two boxes. Boxes are called adjacent if they're next to each other. So this box, this middle box, and this rightmost box, they're adjacent, but the leftmost box and the rightmost box, they're not adjacent. We could also say if they share a common side. Oh well. So boxes are adjacent if they're next to each other. On and Bharati, those obviously they're not really the Anglo-Saxon names, so I'm sorry if I'm mispronouncing them. I'm sorry if it's your name out there and I'm mispronouncing it, but that's how I'm choosing to do it. Really, it's the A and B that we like, but diversity is always a good thing. So we don't just have the usual Alice and Bob. So On and Bharati take alternate turns. Whoever initials the last empty box wins the game. The game begins with a row of 3 boxes. We're in A part now. On initials the middle box. Explain why this move guarantees him a win no matter what Bharati does. Okay, so On initials that middle box. So we would then have to ask ourselves, what can Bharati do? Okay. Well, they can put a B in here or here. You know what? Let's actually draw out things with initials. We'll actually start looking at the question. So what does On do? He puts an A in the middle. Okay. So the first thing I noticed there are no pairs of adjacent empty boxes. I think I'm spelling that right, but I just want to double check. I may not be spelling it, or I may not be pronouncing it right, but I can at least guarantee I'm spelling it right. Right, these are the only 2 options for Bharati. We can either put the B on the left or we can put the B on the right. So in either case, so what we've done is we explained what happened in the first move, and we're just observing. We noticed what could Bharati possibly do? Where could the B go next? There are no pairs of adjacent empty boxes. So what's left? It's got to be a single box, and there's 2 choices for single boxes. But at this point, we can see that, well, it's the end of Bharati's turn. So where's that next A going to go? Well, it's got to go in one of those single spots, and the winner is the person who fills the last empty box. Alright. So no matter what happens, we got 2 places the B can go. But it doesn't really matter, because in either case, that last A is going to fit up the empty box, and On's going to win. And it's going to be one of these 2 scenarios down here. That's what the final sort of board or set of boxes looks like. So, all we did was explain why this move guaranteed him the win no matter what Bharati does. Well, we explained that. We showed what the game looked like. We showed that Bharati has these 2 possible moves, but that no matter what, On will win on his next go. So that concludes part A. We gave a nice quick explanation. Really, all we did was explain the game in its very simplest form. We just said where could the B possibly go, and then the A's got to go in the remaining spot. So not a whole lot of strategy involved in part A. Hopefully, as we move into B and C, we'll get a little more strategy going on. Alright. Now the game begins with a row of 5 boxes. Suppose that the following moves have occurred. So we have the start and everything's empty. And On places an A in the middle. I'm guessing the middle might be a very good strategy. Just thinking out loud here. And the B, for Bharati's move, goes over here on the very left. Okay. One might also know that with the A in the middle, B going over here is no different than B going over here. There's certainly a symmetry to these row of boxes. Alright, question in B part. Show a move that On can make next in order to guarantee he will win. Explain how this move prevents Bharati from winning. Okay. Well, what we might do is we might experiment a little bit. Okay, we might guess some places that A could go. So let's take a look. So we're just experimenting here. This would be done on rough paper. If you have any, I wouldn't include this in your final answer, but obviously I only have the one notebook here open. Got an A in the middle. You know what? I think I'm going to give these guys different colors. Just to make things a little more interesting. So A goes there. Make B orange. So this is the setup we're looking at. So what could On's next move be? Well, we could try here. I mean, there's really only 3. Well, not 3. There's a couple possible moves he could make. He could make a single move here, as we're going to try. A single move here, a single move here. Or he could make a double move here. So there's 4 possible moves he could have. But let's try there. So we're guessing that the A goes there. So what can Bharati do to try and win? Right? We have to put ourselves in sort of the mindset of Bharati and ask, okay, how can I try and win from here? And if we remember the rules of the game, we remember that we can fill in 2 adjacent empty spots. Alright, we'll fill all these guys in at once. So we can have B, 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 and the 2 A's in the middle. And that would mean Bharati filled in the final spot. Okay? Alright, so if there's a way for B to win right away, they're going to take the win from A as soon as they can. They're not going to say, oh, I could move here, I could move here. So we're really looking for that win. So obviously trying that spot didn't work. So what we could do is we could try other things. I mean, this double spot worked for Berardi, so maybe we could try filling the double spot here, but how about we just move one empty space over and try right here? You know, we're just experimenting a little bit. If you see an easy way to win, of course, write that up. But if you don't know what you're looking for, this board game is small enough that we can experiment. And it's always a good idea to experiment on the small questions, if you have time, because, I mean, this is a B part. For all we know, C part's going to involve a really, really big board, and our experimentation with the smaller case can help us recognize patterns for solving the larger case. Okay, that's sort of a general rule of thumb. Really explore the smaller cases if you have time. So now we'll try there. So, where can the next initial B go? One, two, three, four. I will fill in what we want to say with the black first. So what do we got? Well, these two A's here are filled, and the B on the left was already filled in. So there's only really two spots that B can go. There's no double adjacent place, so he can't fill in two at once like he did up here to win. Okay. And this is very similar to question A. Very similar to question A. B can go here, but then A will go here. Or B can go here, and then A will go here. So I think we've stumbled across a win, but we just need to explain it. Let's just double check before we start writing this up in earnest that we just need a move. Show a move that On can make in order to guarantee he will win. Okay, so we just need a move. We don't need to explore the other ones. For those of you who are curious, try and work out them. Try and work them out on your own. Obviously, we know this spot doesn't work. This one will. We're going to write that up. Taking this this rightmost spot, and that'll also do it. Taking both spots pretty quickly, you can see it won't work. You can fill a B in there, but write it out and try and practice your writing up skills. Do case-by-case analysis, that sort of stuff. We won't change colors at this point. We were only really changing colors for our experimentation, and this keeps our solution colors more in line with our solution in part A. B, B, A, blank. B, blank, A, B. So those are Barati's possible moves. So then On wins by filling the remaining space. Okay. We explain what box he chooses. We explain that at that point, no matter what Barati does, you can go left, you can go right, leaving one empty space for On in order to win. Okay. So we experimented a little bit. We could have fleshed that experiment out a little more. We could have, impressed the markers by explaining exactly which places A can go that win, and which cause Barati to win in some cases. But really, we were just asked for a move. So, got our question done. We move on to C part, and maybe it's a little more complex. Alright, so again, the game begins with a row of 5 boxes. Suppose that the following move has occurred. Okay, so we start, and then On places in the second from the left. Okay, the second leftmost spot. Show the 2 possible moves. Okay, so now we're asked to sort of find all the winning moves, I guess, that Barati can make next to guarantee she wins. Explain how each of these moves prevents On from winning. Okay, so this might call for a little more experimentation. That's okay. A cursory glance suggests the B can't go there, because then we have the 1, 2, 3 case, and On knows how to win. Just does the middle box, and there's nothing left that can be done. So we're likely going to have to move somewhere over here. Actually, if B does any single box, it'll reduce down to the 3-box case. That's interesting and kind of elegant, and might hint at further generalization of this game. Maybe A always can win if it's an odd box thing, and then B has to sort of have an even number of boxes available. I don't know. The question's asking us to do something. I'm just spinning my wheels and thinking theory and ways to extend this problem, but that's not what we're here for. We're here to solve the problem, so let's take a look at it. So it's time for a little more experimentation. One, two, three, 4. So that's where that A is. We're experimenting, so I'm going to switch the colors just to make it nice and neat and a little more exciting. So, get an A there. Now I already suggested why this leftmost one won't work, but if we want to, we could add it for a sense of completion. Just start moving left to right. But, yeah, let's do that. On has a winning strategy. Right, we just need to take this middle square here, and then we know from part A that there's nothing that can be done. On's going to win. Okay, so let's try another. One, two, three, four. Okay, we still have A right there. And we'll just keep moving to the left. Sorry, to the right. So this still isn't working for us. Really, any place we stick that B, as long as it's a single B, we're going to have 3 boxes left over. So it's not going to work. Alright, so what can Barati do? Well, she can try 2 adjacent boxes. Now, wouldn't you know it, there's only 2 sets of adjacent box moves, and we are asked to find exactly the 2 moves that she can make. So I'm betting these 2 are the only ones that'll work. We have an A over here. So we sort of moved seamlessly from our experimentation, and this is part of our explanation. Single Bs will always leave 3 boxes, giving A the win by part A. We can add that in as our little solution. No matter which he chooses, Barati has a winning strategy. Giving her the win. So we experimented a little bit. We realized single Bs will not work. They will always give On the win based on our work in part A. So that means we had to have Barati pick 2 adjacent empty squares. And that left On with 2 different choices. Or, sorry, 2 empty boxes, neither of which are adjacent. So he has to play single boxes. And no matter which one he chooses, Barati will just, sort of waltz on over and fill in the last one. And that gives her the win. So our experimentation we could have just erased the word experimentation and just said, let's try a few, and then that sort of justifies why a single box won't work. So explain how each of these moves prevents On from winning, because he's forced to play single boxes. There's 2 left, so he's got to take one, and then the other one is ripe for a little bee to be put into it. So it's a good little game. I wonder, as I mentioned before, I wonder what would happen if we were to generalize this. Is there a particular strategy On always has? Is taking the middle spot always the best? I have no idea. But, it's an interesting little game. I enjoyed it. If you enjoyed it, throw a like on the video. But other than that, let's end the video here. We'll take a look at question number 3, which also has 3 parts. Does 4 have 3 parts? Yeah, so we're really answering 12 questions for this contest. But we'll get into that in the next video. So thank you so much for watching, guys. Again, if you want to, you can like the video. But if not, I'll see you guys for question number 3 on the 2005 Friar. Thanks for watching.